Believe it or not, this question 8 from the 2024 AIME-1 is actually one of the easiest questions on the exam. The only difficult part about this is the arithmetic involved, but besides that, it's actually extremely simple to set up. So let's take a look. Pause the video and try it for yourself if you can. Just be careful to read it carefully, think about what they're asking you for and why, and then get started. Okay, so let's just quickly read it and get on the same page. So 8 circles of radius 34, that's what we're shown over here. They're sequentially tangent, so each one touches the other. And you can also represent this as 2024 circles of radius 1. Right? So they'd be smaller and they'd be like this, and they would also be sequentially tangent. Now they're asking us for the inradius of the triangle, and then of course you need to find it as a fraction and then sum the numerator and denominator so you can get it in the desired format for the exam. Okay, so let's see. We obviously need to set up some equations so that we can actually go ahead and find these values because we don't really seem to be given too much information. But well, what's going to be in common? They're both along the side BC, right? The 8 circles and the 2024 circles. So maybe we can express the radii of the circles and then something with that and equate them and then find the values if we can. So let's try that and see, right? So what do we have here? We're going to have 34 plus 34, so on, so on, so on, so on until here, then another 34. So in total it's 8 circles minus this end minus this end. So that's 7 times 2 times 34. That's that length over there. And then to find this length until here and this length over here, we have to do some light trigonometry, right? So this is going to be b over 2, right? Because it's an angle bisector. This is going to be b over 2 as well. And so to find this length, we know what the radius over here is, right? So this is going to be cotangent of b over 2 times the radius, and then this over here is going to be cotangent of c over 2 again times the radius, and when you add them together you're going to get those lengths. So we have the radius times this plus whatever else we have plus this length over here. So let's not write r over here because we're going to need that later for the Inradius probably. Let's see, what is our radius over here? It's 34, so we can just pop that in over here. And then we know that the rest of this is pretty simple. It's 14 times 34. Okay, and all this is equal to, of course, just BC. Let's do the exact same thing with the one circle, with the 2024 circles of radius 1. And what are we going to have? Well, we're going to have radius 1. It's actually going to follow the exact same format. And over here, you might notice, if you're shrewd, that we have cotangent of b over 2, cotangent of c over 2. It takes quite a bit of time to write that again and again. So it might be smart to just call this x, right? And that's what we're going to do moving forward. I just wanted to demonstrate here that it's the same thing, but yeah, we can just call that x in the future. And so now what do we have? We have 34x plus 14 times 34, and I should obviously not write the x like that, right? That's pretty confusing. Is equal to x plus 2023. I'm not going to do the math over here. Of course, if you're taking the exam, you don't really have a choice. You have to do it. But I think the final answer you get here is, obviously I checked the solutions for this, right? I can't do this. I mean, I can do it in my head, but it'll take very, very long probably. But yeah, I think it works out to be 1190 over 11. Okay, that's not a flex, by the way. It's not impressive at all, but this is basically what we get, right? And if you want to estimate this is probably about 108, something like that. Okay. So we found x. Now this doesn't really give us the Inradius, but what can give us the Inradius? Well, think about this. What is the Inradius? The Inradius, so what is the incircle? The incircle is something like this, touches all the sides, and we have this radius here and this radius here. But importantly, that radius along with x is enough to give us BC. We know that Rx is equal to BC. But what else is BC equal to? It's just equal to x plus 2023. Or you can use the other equation, but this is just a little bit easier. So from here, we know that R x minus x equals 2023. So what does that mean? That's R minus 1 is equal to 2023 over x, which means now you have to do the division, unfortunately, right? There is a lot. That's why I said the arithmetic is the hardest part of this question. But yeah, so this means R is equal to x plus 2023 over x. And now you need to plug in the value of x. Now there are different ways you could do this. It's probably easiest to plug in x, solve it, and then add 1 manually at the end. But ultimately you're going to get some fraction. I'm going to check up on what the answer is very quickly, just so that obviously I can give that to you. That's the point. That's why you watch the video. But yeah, I mean, I'm not going to calculate that right now. I'll just give you the answer. Okay, so I'm back, and I'm back with the answer. The final answer is r equals 192 over 5, which means our final answer is the sum of those, which is just 197. And that's it. Now, yeah, I took a lot of time explaining this. On the test, of course, you'd probably just be able to go a lot faster. However, it would take you a lot of time to do the calculations accurately, unless you're very fast at mental math, but still the numbers are very messy. So be careful with that. Remember, all AIME question 8s aren't going to be this easy. Maybe this wasn't easy for you, maybe it was harder, right? Because all questions are different, right? Everyone has different strengths. So hopefully you understood the solution at the very least. And if you didn't understand it, that's completely fine as well. Just ask me a clarification question, or give me a timestamp if I explain something wrong in the comments below, and I'll try to help you. If I can't help you, hopefully someone else who's watching the video can. I know my explanation is probably biased in whatever made the most sense to me. So just in case other solutions make more sense to you, I'm going to link the AOPS discussion for this question down below in the description, and then you can access that. There are probably going to be other solutions there, including other video solutions, so those might be helpful for you to consider as well. But yeah, that's it for this video. Hopefully you enjoyed. If you did, please make sure to like it up, and also subscribe, because I've been losing subscribers recently and it's very disconcerting. So please do that for me. Thank you so much, and I'll see you in the next video. Bye bye.